Hi guys, today in this ed puzzle you are going to learn how to calculate the 6 trig functions from a given coordinate point. You are going to continue to work with reference triangles, which we did yesterday in class, and standard angles, which we did Monday in class. Materials that you will need, your toolkit. The first examples we will be in your toolkit, and then your workbook. Your practice examples will be coming from your workbook. If you don't like your score at the end, feel free to go back and watch this video later, and I will take the highest of all of your scores. So let's get into it. We're going to start in Toolkit Section 3, page 2, with ASTC. ASTC is an acronym. It tells you places in the quadrants, okay? So we're going to go in quadrant order. Quadrant 1 is the A, 2 is the S, 3 is the T, 4 is the C. How do I remember this? All students take calculus. If you can remember that sentence, all students take calculus, you can remember the order of ASTC. What does ASTC actually mean? It tells us the quadrants that each trig function is positive in. So the A means that all of the trig functions are positive, and all of their reciprocal trig functions are positive as well. So the remaining 3 trig functions, secant, cosecant, and cotangent. The S means that sine is the only one that's positive in quadrant 2. Sine is positive, cosine is negative, tangent is negative. Their reciprocal functions are the same as these. So the sine's reciprocal function is positive, cosine's reciprocal function is negative, tangent's reciprocal function is negative. The T means that tangent is the only one that's positive in quadrant 3. So sine and cosine are negative. And then in quadrant 4, it tells us that cosine is positive, meaning that sine and tangent are negative. So again, all students take calculus. A, everything's positive. S, only sine is positive. T, tangent is positive. C, cosine is positive. So in your Delta Math, you have some examples similar to these. These aren't in your toolkit or anything, but I felt like they might be beneficial for when you're doing your Delta Math later. It says, in what quadrant would our reference triangle fall in if? Well, let's think about the information that we're given. Sine of theta is greater than 0. So what does that mean in terms of positive negatives? Well, if a number is greater than 0, it means it's positive. So the piece of information that this gives us is that sine of theta is positive. Well, where is sine positive? In ASTC, sine is positive in the all and in the students, because S stands for sine. So that tells me that my answer's got to be either quadrant 1 or 2. I just have to look at the second piece of information. So the second piece of information is that cosine theta is less than 0. So less than 0 would mean that cosine theta is negative. Well, with ASTC, I know that cosine's positive in 1 and 4, which must mean in turn cosine's negative in 2 and 3. So if we analyze our answers, I knew that from sine is positive, it had to be 1 or 2, and from cosine negative, it has to be 2 or 4. So what they have in common is 2. So the answer for this would be quadrant 2. And let's analyze quadrant 2 and see why it makes sense. In quadrant 2, sine is positive and cosine is negative. It's the only one of the 4 quadrants where both of those things is true. So my answer for this one would be quadrant 2. Let's try another one. In what quadrant would our reference triangle fall in if? All right, so let's look what we know. Sine of theta is less than 0. So sine of theta is negative. Well, in ASTC, sine is positive in 1 and 2, all in S. So that would mean that it's negative in 3 and 4. So my answer is going to be either quadrant 3 or 4. Let's look at our other information. Tangent theta is less than 0, meaning that the tangent theta is negative. So let's look at all students take calc. This tells us where tangent is positive. It's positive in all and T for tangent, which must mean in turn that it's negative in 2 and 4. So I knew that my answer had to be either 3 or 4, and now it has to be either 2 or 4. So what do they have in common? 4. Let's see why this one makes sense. Sine is less than 0, sine is negative. Tangent is less than 0, tangent is negative. This is the only quadrant where those two things are true. So my answer for this one would be quadrant 4. We're going to take a moment and have you practice one. In what quadrant would our reference triangle fall in if tangent theta is greater than 0 and sine of theta is less than 0? Well, tangent theta being less than 0 means that tangent theta is positive, and sine of theta being less than 0 means that sine is negative. So let's figure out what we've got. Well, all students take Calc, tells me where my trig functions are positive, and tangent is positive. So it's going to be 1 or 3. All students take Calc, tells me where my trig functions are positive. So I know sine's positive in 1 and 2, so in turn it would be negative in 3 and 4. So what do these two things have in common? Quadrant 3. Tangent is positive in quadrant 3, sine is negative in quadrant 3. So the answer for this one would be quadrant 3. So now we're going to head back to our toolkits and we're going to do some examples. It says, let theta be any angle in standard position whose terminal side contains the point -5, 3. Find the 6 trig functions for theta and find the reference angle for theta and the standard angle. So there's a lot going on here. First thing I see is that I have the point -5, 3. So if I was just plotting this point blindly, the x value is -5 and the y value is 3. So just kind of labeling this out. This would be an x value of -5 and this would be a y value of 3. So that point falls right here. And I'm connecting that point because it's a terminal side. I'm connecting it to the initial side. So the initial side is that we learned on Monday. The initial side starts here with the x-axis. And then the terminal side goes from the middle point to that point, right? So this is our angle. And let's think about common sense, logic-wise, what we know about our angle. Well, this is 90 degrees up here, and this is 180. So from this starting point to this ending point, that standard angle's got to be somewhere between 90 and 180. So when we get our final answer, we can double check if we're right because that standard angle should fall between 90 and 180. All right, let's see what else we know. Yesterday we learned how to make this thing called a reference triangle. The reference triangle is the terminal side, which is this side length, the x-axis, and then we drop that down. So this would be our reference triangle, and our reference angle would be this one. We'll call it theta. And let's think about what we know about our reference triangle. Well, we went to the left 5. So this distance here is 5 units. And we went up 5. So this distance here is 3 units. And so we have a right triangle where we know 2 of the 3 legs. So we could use Pythagorean theorem to find my third leg. Leg 1 plus leg 2 equals the hypotenuse. And so we end up with 5 squared plus 3 squared, so 34 is equal to c squared, and so we end up with the square root of 34. Now I would reduce that if I could, but it isn't something that has a perfect square factor, so I'll just leave that as root 34. All right, so now I have my reference triangle. I have all the sides of my reference triangle. I know that my standard angle is this one in red, and my reference angle is this one in blue, and now I just need to figure these things out. So let's think about what we know about sine of theta. Well, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then their reciprocal functions are just those things flipped. right? So I'm just flipping the parts of the triangles. So I should be able to figure this out based on my reference angle theta. So if sine is opposite over hypotenuse, the opposite side of this theta is the 3. So 3 over the hypotenuse is root 34. And then cosecant is hypotenuse over the opposite side length, so that just flips. We know that in math, we can't leave a root in the bottom, so I'm just going to rationalize this part by multiplying the top and bottom by root 34. So I get 3 root 34 over 34. All right, so that takes care of that first one. Cosine is adjacent, so the adjacent leg would be the one next to it, which is 5 over the hypotenuse. And secant, which is its reciprocal function, would be the hypotenuse over the adjacent leg. All I'm going to do here is rationalize this 34. And then finally, tangent would be the opposite leg over the adjacent leg, and cotangent would be the adjacent leg over the opposite leg. All right, so we've got our fractions. Now, what does this have to do with ASTC? Well, we're in quadrant 2, so let's think about what we learned about quadrant 2. In quadrant 2, sine is the only positive function. So sine should be positive numbers, which means that cosine should be negative and tangent should be negative. But why? Well, let's think about what we know about this triangle. That 5 was 5 units to the left, so it's really a negative 5. So everywhere in our problem where we had a 5, it's really actually a negative 5, which is going to make all of these fractions become negative numbers. So that's where the ASTC comes in. Our sine is positive, our cosine and tangent are both negative. All right, so now we need to find our reference angle. To find our reference angle, we can use either the sine, cosine, or tangent inverse. I recommend for this one using the tangent inverse because that's the only one of these ratios, these fractions that don't have a root in it, that doesn't have a root in it. So I'm going to do the tangent inverse. Now I'm going to do 3 over 5 because when we're working with a triangle, we're working with side lengths. So even though there's a negative here, the negative only tells me direction. The actual triangle itself has a leg of 5. Negative 5 as the leg doesn't make sense. So if you do the tangent inverse of 3 over negative 5, you're going to get a negative angle. It's not going to make sense. So when we find our angles, we're going to treat them as absolute values. We're not going to put the negative symbol in. So I'm going to do the tangent inverse of 3/5. Make sure your calculator is in degree mode before you do it. So tangent inverse of 3/5. This is my reference angle. If I do the tangent inverse of 3 over negative 5, I get the same angle, it's just negative. Reference angles aren't negative. So we're going to use the absolute value of the side lengths. So my reference angle is 30, and we'll round it to 2 decimal places, 30.96 degrees. All right, so let's think about what that means about our standard angle. Well, together, our reference and standard angle form this 180 degree angle. So if I know that the blue angle here is 30 point something, I need to go the remainder of the 180 for the standard angle. So we could do it that way visually, or you can remember that yesterday we made rules for all of our quadrants. And our quadrant 2 rule said that our reference angle equals 180 minus our standard angle, or our standard angle equals 180 minus our reference angle. So it doesn't matter which rule you use. We're going to use this one since we're trying to solve for our standard angle. So I'm going to do 180 minus my 30.96 to get my standard angle. Remember what we said. We knew that our standard angle needed to be somewhere between 90 and 180 since it's falling in quadrant 2. I'm getting 149.04 degrees. I know that's a lot to throw at you. Let's do one more in your toolkit that's similar to that before you try one on your own. So we've got this information, and now we're working with the point 2, -6. So the x value of 2, the y value of -6 puts us here. Remember, this is the initial side. The angle I'm working with starts here on the initial side and works its way around. It's almost 360, but not quite the full circle. What I know about this angle is it falls in quadrant 4, which is somewhere between 270 and 360 degrees. So when I get this final answer here, I know it should be something between 270 and 360. All right, so I've got that. Now I want to create my reference triangle. Remember, the reference triangle is with the terminal side and the x-axis. So this is my reference triangle. This is my reference angle right there. So let's think about what we know about this reference triangle. We went over x units 2 and down y units -6. So what I don't have is the hypotenuse. So to find the hypotenuse, I'm going to use Pythagorean theorem. Just make sure if you're keeping the negative, you're using a parenthesis around it. So we're working on finding this side length. I get 40 is my c value. Sorry, 40 is my c squared value. So root 40 is my c value. Now I'm going to write this in simplest radical form because I know there is a perfect square factor that goes into 40. So c is 2 root 10. My hypotenuse is 2 root 10. All right, so we've got all that. I'm just going to tie in my ASTC quick. So all students take calculus. We are in quadrant 4, meaning that cosine is going to be my positive one. Everything else should end up being negative. All right, now let's work our way through these fractions. Sine is opposite, which is -6. That's where the negative's coming from. Over hypotenuse, which is 2 root 10. And cosecant is hypotenuse, which is 2 root 10, over -6, which is where the negative's coming from. Now, 2/6 in this cosecant can reduce to 1/3. So I'm just going to reduce that fraction. And then over here, I'm going to have to rationalize the denominator by multiplying by root 10. So I get -6 root 10 over 2 times 10, which is 20. And then 6/20 reduces to 3/10. So I'm just working my way through rationalizing that. Cosine is adjacent over hypotenuse. And then I can flip that for the secant, and these are positive. Now what happens for the secant is the 2's cancel out, and I just get root 10. And over here I have to rationalize. So I get 2 root 10 over 2 times 10, which is 20, or root 10 over 10 when I rationalize the denominator. Sorry, root 10 over 10, not root 10. And then the tangent is opposite, which is -6, which is where the negative's coming from, over adjacent, which is 2. And then if the flip side of that would be 2 over -6. That's where the minus is coming from. I can simplify these both. So -3 and -1/3. All right, I need to find my reference angle, so I'm going to use one of these 6 trig functions, actually one of the 3, because we only have a sine, cosine, and tangent button in our calculator. I'm going to go tangent because it's the only one that doesn't have a root in it. And to solve for the angle, I have to do the inverse. So I'm going to do the tangent inverse. Just remember, it's not the tangent inverse of -3, it's the tangent inverse of 3. If you do the tangent inverse of -3, you're going to get a negative number, which hopefully tells you that you're doing something wrong. So I'm going to do the tangent inverse of 3. The reason that we keep it positive is we're talking about triangles, and triangles need to have positive side lengths. So my reference angle comes out to, when I do the tangent inverse of 3, 71.57. And then to find the standard angle, if this is 71, well, this reference angle of 71 completes the circle. So together, my reference angle and my standard angle make a full circle of 360. So you can figure it out visually like that. Or you can remember yesterday that we worked on these rules in our toolkit. And the quadrant 4 rule says that the reference angle equals 360 minus the standard angle, or the standard angle equals 360 minus the reference angle. We're going to work with the bottom one since I'm trying to solve for the standard angle here. So I'm going to do 360 minus that standard angle. Remember what we said in the beginning, which because this is in quadrant 4, this should fall somewhere between 270 and 360. And I get 288.43 degrees when I do that subtraction. So at this point, now that we've done these two, I'm going to have you try some in your notes, and then we'll get some answers posted through this ed puzzle. So you're going to go to workbook page 16, and you're going to work through 10 and 11. Here's question 10. I'm looking for you to plot that point, and the first question that I have for you is, which quadrant does your terminal side fall in? So if I'm plotting the point -5, -4, my terminal side falls in quadrant 3. Now you're going to make your reference triangle with your x-axis. So here's your reference angle. My next question for you is going to be, what is the measure of the hypotenuse? Well, we went over 5 and we went down 4. So if we do Pythagorean theorem on this, we end up with, let's see, 25, 16, 41. So root 41 would be my hypotenuse. All right, my next question for you is, which of these trig functions is going to be positive? Sine, cosine, or tangent? Well, A, S, T, C, we're in quadrant 3. That tells me that tangent is going to be positive. Everything else is negative. All right, and now we would be filling in our ratios. So my ratio for sine would be opposite over hypotenuse, -4 over root 41. And then I could flip that here, root 41 over -4. You would have to rationalize this one by multiplying by root 41. Cosine would be adjacent over hypotenuse, which again is negative because the 5 was to the left. And then if I flipped that, it would be root 41 over 5. You would have to rationalize this one. So my question for you is, what is the tangent of theta? What ratio would you have? I know it's going to be positive, but what's its ratio? Well, tangent is opposite over adjacent. Well, no. Opposite of the theta is -4, and adjacent is -5. That double negative makes it a positive 4/5. And then the reciprocal of that would be 5/4. All right, now take your time to choose which of these trig functions you're going to use and find the reference angle. Remember, the reference angle should be something between 0 and 90 degrees. It should be positive. I'm choosing to do the tangent inverse of 4/5 because there's no root in that. And when I do that, I get 38.66 degrees. Finally, I'm asking you to calculate the standard angle. It should be some angle in quadrant 3. Well, I know my standard angle is all of this. So if I take away the reference angle, I just have a 180 degree angle. So my quadrant 3 rule says that to find the standard angle, I do my angle minus 180. So my standard angle equals, plus 180. So my reference angle plus 180 is going to be my standard angle. If we work through the equation, right? So it's that 180 degrees plus 38.66 more. So in this case, it would be 38.66 plus 180. So my reference, my standard angle is 218.66, which is between the 180 and the 270 of quadrant 4. We're going to end this ed puzzle here and allow you to do some practice in your delta math. So your delta math is due on the 5th. You can do these examples. If you need to see an example similar to this, I've got examples posted on the back board. Now my examples aren't going to be the same numbers as yours, but they'll look similar. And if you need further explanation, I have a video of me going through those examples on Canvas.